Hey everybody, Mr. Conan here, and today we're going to talk about quadratic functions in vertex form. Now, we write vertex form as f of x is equal to a times x minus h squared plus k, where hk is the vertex. Again, mathematicians aren't really that creative, that's why we call it vertex form. So we're going to discuss the following questions. How does h change x squared? How does k change x squared? And how does a change x squared? How do all these values kind of impact the graph of our quadratic based on the parent function? So, first off, we'll look at how does h change x squared. We're going to have a horizontal translation here. Now, what we're going to do is we're going to look at these two graphs. On the left, I have f of x is equal to x squared, and on the right, I have g of x is equal to x minus 2 squared. Now, we've already discussed the parent function x squared before. We know if we plug in negative 2, we get 4, negative 1 gives us 1, 0 gives us 0, 1 gives us 1, and 2 gives us 4. Now, in the new situation, when I plug in x, if I have negative 2 minus 2, that's going to give me negative 4. Negative 4 squared is 16. Negative 1 minus negative 2 is negative 3. Negative 3 squared is 9. 0 minus 2 is negative 2 squared is 4. 1 minus 2 is negative 1 squared is 1. 2 minus 2 is 0, squared is 0. So let's start graphing these functions. On the left, I have all my points, and the graph looks like this, our parent function. If I start putting my points from the other one, 16 doesn't fit, 9 doesn't fit, but 0, 4 does, 1, 1 does, and 2, 0 does. So what we can do instead of quitting is keep listing points. If I plug 3 in, 3 minus 2 is 1, 1 squared is 1, and then 4 minus 2 is 2, squared is 4. So I can put those points on. And if you look at this graph, from the vertex, the 0, 0, if I go to the right 2, I end up with the new vertex of my function over here. So this is moving a horizontal 2 units to the right. Let's talk about how k changes our x squared function, a vertical translation. Again, same thing as last time. When I plug those values into x squared, I get all of these, 4, 1, 0, 1, and 4. If I plug negative 2 in here, well, since I'm adding 3 to what we did before, I know 4 plus 3 is 7. I know 1 plus 3 is 4. I know 0 plus 3 is 3. I know 1 plus 3 is 4. And I know 4 plus 3 is 7. So when I graph those points, oh, did you look at that? This graph has all the same points as the other one, but they're moved up 3 units. So we have a vertical translation. Now, stretches and compressions. Let's say my a value is different. So again, we know what the function x squared looks like. Well, if I have 2x squared, that just means I'm going to multiply the end result by 2. So 4 times 2 is 8, 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2, 4 times 2 is 8. When I graph these points, it looks something like this. If you notice, the function's increasing a lot quicker than the parent function. This is what we would call a vertical stretch. Now with my other function, h of x is equal to 1/2 x squared, I'm going to multiply my final answer by 1/2. So I had 4. 4 times a half is 2. 1 times a half is 1/2. 0 times a half is 0. 2 times a half, 1 times a half is a half. And 4 times a half is 2. So if I graph these points, oh, look at that. My function's taking longer to increase. If it increases slower, we call this a vertical compression. Last but not least, how does a change x squared, positive or negative? So, we already know what x squared looks like. Let's look at the negative version of that. If I had 4 as my y value and I multiply by negative 1, I get negative 4. Same thing with all the other values. Negative 1, 0, negative 1, and negative 4. So when I graph this, if it's negative, it flips over the x-axis. The a value will determine whether or not we're going to be open up or down with our parabola. So, in conclusion, the h determines the horizontal shift. That means the x value of the vertex determines how we move either to the left or to the right. If we are subtracting that h value, we're moving to the right. If we are adding it, we move over to the left. K determines the vertical shift, so the y value of the vertex tells us if we move up or down. If we're adding k, we shift up. If we're subtracting k, we shift down. The a determines the stretches or compressions or opening up or down. If the absolute value of a is greater than 1, it's a vertical shift or stretch. If the absolute value of a is between 0 and 1, it's a horizontal stretch. If a is greater than 0 or positive, it opens up. If a is less than 0, it opens down. Got it done in 5 minutes. Thank you guys. I'll talk to you later.